Hello, pre-calculus class. Today's lesson will be using matrices and specifically row operations to solve system of equations and application problems. In this warm-up, go ahead and answer the two questions. You'll note the second question you've seen before, but now we're going to solve it using matrices. Pause the video now. All right, so first of all, what does this mean on the first problem? Well, it says replace row 3 with -2 times row 1 plus row 3. And that's one of the rules that you can follow or do when you're playing or using row operations. The bottom problem, we wanted to set up the curve fitting problem as an augmented matrix. So the first thing you recall, we have our quadratic equation, and we have 3 points. So for each point, we're going to plug those into the equation for x and y. So what I did with the first point is just show you y, -4, equals a times x squared plus b times x plus c. So when that simplifies, you end up with -4 equals 1a minus 1b plus c. So my coefficient matrix, if you think about this as a, b, and c columns, is 1a minus 1b plus 1c equals -4. And you do the same thing for the second and third points. We will solve this later. In this next example, we're going to solve this system of equations, 3 variables, 3 equations, with row operations. And note that I say it's a dependent system. In a dependent system, it means you're going to have infinite solutions. So let's see what happens and how we can recognize that it's a dependent system. First thing we need to do is set up our augmented matrix. And here we have that. The next thing we need to do is try to get to a 1 in the upper left corner. So I notice that I have a 6 here and a 5 here. And if I take and replace row 1 with row 1 minus row 3, we will end up with a 1 there. So we're not changing row 2. I'm just going to rewrite that. We're not changing row 3, so I will rewrite that. And we're only changing row 1. So 6 minus 5 is 1. -1 minus 1 is -2. -1 minus -1 is -1 plus 1, or 0. And 4 minus 3 is 1. All right, first step is done. Next steps is to get zeros here and here. So how are we going to do that? Well, the easiest thing is to multiply the top row by 12 and add it to the second row, and multiply the top row by -5 and add it to the third row. So row 2 will be 12 times row 1 plus row 2, and row 3 will be -5 times row 1 plus row 3. Okay, I did that quickly. I took your top row times 12 and added it to the second row, and then the top row times -5 and added it to the third row. Okay, so we've got our first column, 1, 0, 0. Our next deal is we need to get a 1 in the second column, second value, right there. So sometimes this is the hardest way to do it. But I think what we'll do is we can just divide the second one. So we'll take row 2 and we're going to divide it by -22. So it equals -1 22nd times row 2. It's not going to be pretty, but it works. So top row doesn't change. Bottom row doesn't change. And the middle row, when you do 0 divided by 22, you still have 0. -22 divided by, or times 1 over -22 is 1. And then, let's see, 2 divided by -1 over 22 is -1/11th. And 4 divided by -1 over 22 is 2/11. All right. Okay, and now we need to get a 0 right here. So the easiest thing to do is we're going to replace row 3 with -11 times row 2 added to row 3. Always use the row above it and using the 1 so that you make a 0. So let's see what happens now. First row doesn't change. Next row doesn't change. We're only changing the third row. When you do -11 times 0, you have 0 plus 0, so that doesn't change. -11 times 1 is -11, plus 11 is 0, which is what we wanted. And then this is interesting. -11 times 1/11 is +1. Added to -1 is a 0. And -11 times -2/11 is 2. Added to -2 is a 0. And that is very odd. Right there, we know we have a dependent system with infinite solutions. So when you end up with something like this where there's no variables equal to 0, you know that we can't simplify any further, and we cannot isolate the values for x, y, and z all in terms of a single number. The key now is how we show our solution. So what we need to do is write the equation of what we have so far. So we know this is x, y, and z. So we've got x minus 2y equals 1. And then we have y minus 1/11 z equals -2/11. And now what we want to do is solve both x and y in terms of z. So it's easiest first to solve y in terms of z. So we know that y equals 1/11 z minus 2/11. So I'm going to circle that. And then I'm going to take that and plug it into up here. So we have x minus 2 times 1/11 z minus 2/11. And we'll just distribute, equals 1. And now we'll distribute that. We have minus 2/11 z and then plus 4/11 equals 1. And now we want to solve this for x. So x equals 2/11 z minus, we'll have 1 minus 4/11 leaves us with plus 7/11. So the way we write our answer is it's the order triple x, y, z such that x equals 2/11 z minus 7/11 and y equals 1/11 z minus 2/11. And that is your answer when you have an infinite set of values. All right, this next example, another 3-variable system, is an inconsistent system. So you're going to see how you recognize when you have an inconsistent system. So the first thing we need to do is set up the augmented matrix. So we have 1, 1, 1, 6. Then we have 2, -1, -1, 3. And 1, 2, 2, 0. So this one should be pretty easy to solve. We already have a 1 in the first level, so that can stay. And the question is, how do we get zeros here? So I'm just going to write my rules right here. Row 2 equals -2 times row 1 plus row 2. And we can just make row 3 equal to row 3 minus row 1. So that'll be the easiest way to do it. So let's see what we get here. And we end up with a 0, -2 plus minus 1 is -3, -2 minus 3, -2 is -12, so you have a -9. And our last one, we're going to take row 3 minus row 1. So we have a 0, 2 minus 1 is 1, 2 minus 1 is 1. 0 minus 6 is negative 6. Okay. Our next situation is we need a 1 in the second row. So I think the easiest thing to do is switch row 2 and row 3. So we end up with 1, 1, 1, 6, 0, 1, 1, negative 6, 0, negative 3, negative 3, negative 9. Okay, so now we need to get a 0 here. So the easiest thing to do will be replace row 3 with 3 times row 2 added to row 3. Move this up a little bit. And when you do that, you end up with no change to row 1, no change to row 2, and the bottom row, the first one's not going to change, but 3 times 1 is 3, added to negative 3 is 0. And then look what happens. We end up with another 0. And then here's where something different will occur. 3 times negative 6 is negative 18, added to negative 9 is a negative 27. Remember, with the last example, and it was dependent, we had zeros across the board in the final roll. Well, this one, what it says is 0x plus 0y plus 0z equals negative 27. And 0 does not equal negative 27. So right then and there, you know it's inconsistent. And that means there is no solution. So you can stop. With this next example, why don't you try it on your own? Notice that this is 4 equations with 3 variables. So you are going to have a 4-row and 4-column matrix. Go ahead and first set up the matrix or the augmented matrix, and then I'll show you that, and then you're going to go ahead and solve it on your own, and then I'll show you the solution. So pause the video here and set it up. Okay, there you have the matrix, and you're going to already have the 1 in the upper right corner, and you just need to get zeros down below. Go ahead and do that on your own, and I'll show you what rules I used and what it looks like at that point. Pause it here. All right, so here you have that. Next thing we need to do is get a 1 right here. So I'm going to switch row 2 and row 3. Make sure you switch the whole thing across. All right, pause it here and try to get zeros down below. We're just going for row echelon form, which means we'll have 1s going along the diagonal and 0s below it. Note, we have more rows than we need here because we really only needed 3 equations if we have 3 variables, and they gave us a 4th. So we'll just keep working though. Go ahead and pause it and get zeros where the 6 and the 2 are. All right, here you go. So by doing these 2 rules that I've listed up here, you end up with these columns. Okay, note we already have a 1 here. So I just need to make this a 0 below it. And we will do that right now. Let's move this up. So in order to do that, we are going to take row 4, replace it with -5 times row 3 plus row 4. And a lot of rewriting here. No change to the top row. No change to the next row. And we're not changing row 3 either. But we are changing row 4. So when you multiply -5 times row 3, the zeros aren't changing. But -5 times 1 is 5. -5 plus 5 is 0, which is what we wanted. And -5 times 3 is -15 plus 15. And look what happens. It better be that way if you have a system where there's 4 equations with 3 unknowns. But now we can solve our system. So I start with the bottom row of numbers, and I have z equals 3. Remember, it's x, y, z columns. Then I have 1y minus 1z equals -1. So we plug the z in. And we add the 3 over. So we end up with y is 2. So we're almost done. And now I can take the top equation, x minus 2y, so 2 times 2, plug that in, and then plus z, which is 3, equals 0. So we end up with x minus 4 plus 3 equals 0, x minus 1 equals 0, x equals 1. So our ordered triple or solution is 1, 2, 3. Done. All right, take a look at this problem. One group of customers brought 8 hamburgers, 6 fries, and 6 large sodas for $26.10. A second group ordered 10 hamburgers, 6 fries, and 8 large sodas for $31.60. The question is there sufficient information to determine the price of each item? So let's start by assigning some variables. So let's see, we have 3 different items. So we're going to say let H equal the price of hamburgers. And let F be the price of fries. And S be the price of a large soda. So far we have 2 equations. The first customer or one group of customers, and then we have the second group. And if you have 3 variables, you really need 3 equations in order to solve the system. So our first answer, is there sufficient information, is no. So we need more information, and here is our third group right here. So we're going to write down all 3 of these equations using the variables we chose before. 8 times the price of a hamburger plus 6 times the price of a fry plus 6 times the price of a soda equals $26.10. Likewise, 10 hamburgers plus 6 fries plus 8 sodas equals $31.60. And lastly, 3 hamburgers plus 2 fries plus 4 sodas equals $10.95. Okay, so now we have our system of equations. And we can solve this. Let's move this all up. We can solve this using matrices. So we are going to set up our matrix. 8, 6, 6, 26, 10. 10, 6, 8, 31, 60. And 3, 2, 4, 10.95. Okay. All well and good, and we can solve this using row operations, but you got to think that this is going to be pretty difficult to do using row operations. So on the next slide, I'm going to show you how to use your graphing calculator to use matrices and find row operations. And then I will give you this answer after we do that. The hard thing here is I'm going to talk through it with the calculator in my hand, but I don't have a picture of the calculator to show you. So we're all pretty much using the TI-83 Plus. And the first thing you want to do is notice the second button. Mine is yellow. Choose that. And then you'll see matrix above the inverse x minus 1 key. It's the 4th down on the left. And it says MATRX. Choose that. It brings you up to a menu. There's 3 options: name, math, and edit. So name is when we're going to try to use the matrix. Math is when we're going to do something on it. So it's a menu of choices. And edit. So we're going to start with edit to enter our information. So go over to edit. Let's put it in A. And we're going to use the matrix that we were just using with the hamburger, fry, soda problem. So that was a 3x4 matrix. So you want to enter your dimensions row by column. So you just enter 3 and then you enter 4. Hopefully you're along with me. And then you can enter in the data. I'm going to write the matrix down so we have it. All right, so there was the 3x4 matrix we had from the other page. If you remember that the first column represented hamburger price, the next was fry price, and last was soda price. And that was your coefficients. All right, so once you enter the data, and it goes across each row, so you can enter a number, hit enter, number, hit enter. Then what I usually want to do is get out. So I hit second quit and get back to my blank screen. But now I have two choices. I can choose Math Menu A or Math Menu B. REF stands for row echelon form, which is what we've been doing, where you have ones on the diagonal and zeros underneath. But RREF actually gives you a matrix where you're going to have ones on the diagonal and zeros underneath, plus zeros up top, and then your numbers. So you can quickly identify, oh, H is this, F is this, and S is this. So you can do either one. I think I'm going to go ahead and use RREF. So go back now, choose second matrix, go to math, choose RREF, which you have to go down a little bit in the menu. You see 1, 2, 3, 4, 5, 6, 7. Keep going. You'll get to A is REF and B is RREF. So choose that. Then you have to go second matrix again and choose matrix A, because that's where you stored when you edited the matrix. And hit enter. And there we have it. The answers. So they give us that H. Well, let me write down the whole matrix that they give us so that you can see it. I got to move this here. A few more notes. Be careful. You may be a different version of what you would get by hand for the REF calculation, and be on the lookout for dependent systems, a row with all zeros, or an inconsistent and illogical result where you have maybe 3 zeros and then some number. But what happens when you do RREF is you are going to see this. So let me write it down. You have a 1, 0, 0, and then 195, telling you that hamburgers equals $1.95 per hamburger. And then our next column is 0, 1, 0, and that is 95, telling you that fries are 95 cents. And lastly, we have 0, 0, 1. So remember, this was HFS. So H is $1.95. F is 95 cents. And S is 80 cents. So that means sodas are 80 cents. And that's how you use the calculator to do a systems of equation row operations for you, which is really nice. Feel free to look at it as well in the REF form. All right, this last problem we're going to do is a financial planning problem. And what's nice about this problem as you read through it is it actually gives you the 3 equations that you're going to be using in order to solve this system. We've solved these systems back when we were doing 3 variable systems before. So the first thing I want you to do is read this over and then write the augmented matrix that this system represents. So we're going to use N, B, and C. For N is Treasury notes, B is Treasury bonds, and C is corporate bonds. So pause the video now. All right, so here is your augmented matrix. You have your first equation where they all add up to $600,000 of investments. And then you have your rate equation, so 3%, 5%, and 6%, all of the principal, and you want to make $25,000 a year through your investments. And then the last one is the relationship between notes, bonds, and corporate bonds. So you want to make sure you are setting it equal to or getting all the variables on the left. All right, go ahead now and use your calculator in REF in order to solve the problem. And here is your answer. So by using RREF, which stands for Reduced Row Echelon Form, I don't think I said that yet, you end up with your investment N in Treasury notes should be $300,000. Your investment B in Treasury bonds should be $200,000. And your investment C in corporate bonds should be $100,000. And that is how you want to take advantage of the calculator and row operations to solve a systems of equation. Feel free now to go back and do the warm-up again using the matrix we found and the reduced row echelon form in the calculator to quickly find that quadratic that goes through those three ordered pairs. And good luck on your homework.